So we're going to start today with a little warm-up reviewing area. So we're going to start by finding the area of a triangle in this first one. Remember that area of a triangle is 1/2 base times height. So 1/2, my base of 17 and my height of 8. Basically, you're just going to plug this into the calculator. I would use 0.5 for 1/2. So 0.5 times 17 times 8. It's going to give me an area of the triangle of 68 centimeters squared. With the area, we do have squared units. Area of a square, length of 6.5. Because it's a square, we know that all of our sides are the same. So 6.5 times 6.5. And we get an area for our square of 42.25. And again, centimeters squared. Formula for the area of a parallelogram is base times height. So we're going to do 16 times 12. So the area of our parallelogram is 192 yards squared. Over the next few lessons, we're going to be looking at volume. This is actually 3 lessons put into one video, and we have a lesson on each one: cylinders, cones, and spheres. Some vocabulary: we have volume, cylinder, cone, and sphere. Volume is the amount of space that something's taking up. The best way to visualize volume is if you take a container of the shape that you're looking at, and if you were going to fill that container with liquid, how much liquid would you need? Cylinder, formal definition is that it has 2 parallel congruent circular bases connected by a smooth surface. This is going to look like a can, like a soup can. A cone, we have that one circular base, and then it actually ends up being half a circle that's wrapped around in order to get that curved surface. This would look like a cotton candy holder or the paper cups that you would get out of drinking water machines. Sphere, set of all points that are a given distance from the center. Excuse me, I'm a little tired this morning. Set of all points from a given distance to the center. This would look like soccer balls, tennis balls, those sort of things. So we're going to start with the volume of a cylinder. Volume of a cylinder is pi r squared h. R is your radius, and h is your height. And basically the reason we're squaring the radius is we want to get the area of that circle. Basically what we're doing is we're taking the area of the circle and we're multiplying it times the height of that piece that's connecting them. So pi r squared is actually your area of your circle. So for right now, I want you to keep writing the formula down because that's going to help you remember exactly what we're looking at. So pi is going to stay pi. Our radius is 5. We're going to square it. And we have a height of 8.3. Your best bet is to plug this all into the calculator at one time. If you don't have a pi key, you can use 3.14, and you'll get pretty close to what we're looking for. So pi times 5 squared times 8.3. And I'm getting an area of 651.9. Because it's a volume and it's a 3-dimensional figure, we're going to cube our units, so centimeters cubed. Same sort of thing here. Volume, pi r squared h. So pi times 5.5 squared times 9. Pi times 5.5 squared times 9. I'm getting an area for this cylinder, or I'm sorry, a volume for this cylinder of 855.3. The way everything is around us would make this a 3. And this would be inches cubed this time. Here we don't have a picture, and if you notice we're being given a diameter of 16 and a height of 20. I don't want a diameter, I want my radius. So in order to get my radius, I'm going to take my diameter and I'm going to divide it by 2, because radius is half of your diameter. So volume is pi r squared h. So pi times 8 squared times my height of 20. So pi times 8 squared times my height of 20. And I get a volume for this cylinder of 4,021.24 inches cubed again. Same thing here, we have a diameter of 12. So to find my radius, I'm going to take my diameter and cut it in 2, giving me a radius of 6. My volume is pi r squared h. So pi times 6 squared times my height of 4. Pi times 6 squared times my height of 4. I'm ending up with a volume of 452.39 meters cubed. I'd like you to go ahead and try these two on your own. Now that you've had a chance to try them, remember the formula. Volume is pi r squared h. So that's going to be pi times 3 squared times 1.8. And I get 50.89 inches cubed. For the second one, you'll notice that we have the whole diameter. So my radius is going to be half of that 12 or 6. So pi times 6 squared times 5. Pi times 6 squared times 5. And I get 565.49 millimeters cubed. So basically now here we're looking at some two-step problems. We have paperweight in the shape of the cylinder, we have a height and a diameter, and we want to know how much the paperweight weighs. Well, we have to know how much the paperweight's going to hold first. We're going to start with volume. So my volume is going to be pi. I'm given a diameter of 2, so I need to cut that in half to 1 and square it. I have a height of 1.5. So pi times 1 squared times 1.5, and we're only getting a volume of 4.71 inches cubed. Now it tells us if each one of these cubic inches weighs 1.8 ounces, what would the total weight be? Well, basically you're just going to take your volume now and you're going to multiply it by 1.8. I'm getting 8.48 ounces for my total weight. So I had to find my volume in order to know what to multiply by. And the reason I knew I had to find my volume is it was talking about my weight with cubic inches. And the only way you're going to get cubic inches is if you're looking at volume. So we want to determine the maximum capacity of the bucket, basically how much can she hold, radius of 6, height of 12. It's still asking for volume, it's just really identifying what the wording is talking to you about. So pi times 6 squared times 12. I'm going to get a maximum capacity of 1,357.17 inches cubed. So So same sort of thing here. We're looking at the average weight. So we have a height of 4 feet and a diameter of 1.5. So we need to do 1.5 divided by 2. And we're going to find out that we're going to use 0.75 as our radius. So we're going to do pi times 0.75 squared times 4. And I'm getting my volume of 7.07 feet cubed. So if the weight of an aluminum can is 37 ounces per square foot, we want to know the total contents. So we're going to take the 7.07 and we're going to multiply it times 37. And we get that it's going to weigh roughly 261.54, and it's still in ounces. 4, I'm going to do 4 up here so we have a little bit more room. So we have the diameter of 6.6. We're going to divide that by 2 to get our radius, or a radius of 3.3. So volume is pi times 3.3 squared times 9.9. You're going to get a volume of 338.7 centimeters cubed. So here we're looking at what's known as a composite solid, and basically we're going to be putting two different shapes together. And you're going to find the volume of each shape and then add the two together. Or in this case, we're going to be subtracting the two. So we have a cube. And I'm really bad at drawing three-dimensional figures, but hopefully this will look somewhat like a cube. So we have our cube. And this cube has a length of 12 on each side, and in the middle there's a circle. That circle has a diameter of 12. We want to find the volume of the bead. Well, that full bead isn't going to have that circle in it. But anyway, you're going to start and you're going to find the volume of the cube. And it's going to be 12 times 12 times 12. Or 1,728. We're going to find the volume of the cylinder. And give us a diameter of 2. So we're going to be using our radius of 1. And our height is going to be the same height as the bead. So our height's going to be 12. So then we're looking at pi times 1 times 12. You'll notice that I didn't say 1 squared, and it's because 1 squared is just 1. So I'm getting 37.7 there. And I want to get rid of that cylinder in the middle. So I'm actually going to subtract these two to get the total volume of the bead. So 1,728 minus 37.7. And the volume of the total bead is approximately 1,690. So here we're still looking at the composite solids. I want you to go ahead and try these two on your own, and we'll go ahead and go over them. So in this first problem, we're actually looking at two cylinders, so you need to find the volume of each one first. So the actual paper towels is going to be pi times 6.5 squared times 28. And my other one is going to be times 2.25 squared times 28 as well, because my height's going to stay the same. So let's figure both of those out. So pi times 6.5 squared times 28. And for the whole roll, I'm getting 3,716.5. For just the roll, pi times 2.25 squared times 28 as well. I'm getting 445.32. We're going to subtract those two. There's 3716.5 minus 445.32. And get a volume of just the roll, so just the bulk of the paper towels, will be 3,271.18 centimeters cubed. Treasure chest, we have our rectangular base, and they're giving us our length, our width, and our height. And the lid of the treasure chest is half a cylinder with a radius of 9. So let's start. And we have our treasure chest, and they're giving us our length of 30. They're giving us our width of 25, and they're giving us our height of 50. So the volume of the rectangle would be length times width times height. So 30 times 50. I'm sorry, I'm writing my numbers wrong. 30 times 50 times 25. So the volume of the whole treasure chest is 37,500, and that's just the rectangular bottom. We have a radius of 9 for our half a centimeter, and if you notice where the lid's going to fit, it's a really bad looking lid, but the height of that cylinder is the same as the height or the length of our rectangle, so 30. So I'm actually going to be using pi times 9 squared times 30. So pi times 9 squared times 30. Now, I need to divide this by 2 because I'm only using half a cylinder. So that gives me 3,817.04 for the lid. I'm going to add that with my 37,500, and I get a total volume for the treasure chest of 41,317.04. So some volume problems for homework tonight. These are all going to focus on the cylinder and the composite cylinder. So today's warm-up before we get into today's volume problems. We have the cylindrical hay bale. Notice it's a diameter of 5 feet. So we're going to use pi times 2.5 squared times our height of 5. And remember, you're going to get a more accurate answer if you put everything into the calculator at once. So we're going to get a volume of 98.17 feet cubed. And then it wants us to know the height, or not the height, the weight. And we know that each one weighs 2 pounds, so we're going to multiply our volume times 2. And we're going to get a weight of 196.35 pounds. Today we're going to be looking at the volume of a cone. The volume of a cone is 1/3 pi r squared h. You'll notice that pi r squared h yesterday from the cylinder. And basically what this is showing is that if we take 3 cones, we should be able to create a cylinder. Like their volumes, the volume of a cylinder is 3 times as much as the volume of a cone. So we have our height of 6, and our volume is 1/3 pi r squared h. And so the 1/3 and the pi are there. We have our radius of 3, so we're going to square that, and we have our height, which is 6. So 1/3 times pi times 3 squared times 6. I'm getting out a volume of roughly 56.55. And again, still inches cubed because we're still looking at volume. 1/3 pi r squared, which is 5, times our height, which is 4. 1/3 pi r squared h. So 1/3 times pi times 5 squared times 4. And I get 104.72 inches cubed. Notice here you're being given the whole diameter, so half the diameter is going to be 3. So 1/3 pi r squared h. 1/3 pi times my radius, which is going to be half of that. My radius is 3 times my height of 8. 1/3 pi times 1/3 times pi times 3 squared times 8. I'm getting a volume of 75.40 meters cubed. Same sort of thing here, we're just looking at it in more of a word problem. So we have the paper cup filled with water. We have a height of 10 and a diameter of 8, meaning that my radius is going to be 4. So 1/3 pi r squared h. 1/3 pi times 4 squared times 10. 1/3 times pi times 4 squared times 10. I get 167.55 centimeters cubed. Total volume of the cones she is filling. Notice she's filling 6 identical cones. So we're going to find the volume of each one. So 1/3 pi 1.5 squared times 9. 1/3 times pi times 1.5 squared times 9. 1/3 times pi times 1.5 squared. I'm getting a volume of 21.21. And she has 6 of those, so that's going to be multiplied times 6. And we get 127.23 inches cubed. So we're back to our composite solids now. And this time we have a cylindrical base and a cone top, so we're actually going to put the two together. So we're going to do our volume of our cylinder, we're going to do our volume of our cone. So the cylinder is pi r squared h. My diameter is 8 feet, so I'm going to using the 4 for my radius, and my height is 4. My cone is going to have the same radius because they're sharing that cylindrical top. So 1/3 times pi times my radius again of 4, and the height of the cone is 5. So do each one separate. So pi times 4 squared times 4, getting 201.06. For my cone, 1/3 times pi times 4 squared times 5, I'm getting 83.78 for my cone. And we want to add the two of them together. So we're going to add that to 201.06 and get a total volume of 284.84 feet cubed. So again, cylindrical base, cone top. Diameter is 8 feet, height of the cylinder is 4 again, so volume of my cylinder is going to be pi times 4 times 4, 4 squared. Volume of my cone is going to be 1/3 pi times 4 squared times my height of 10. So pi times 4 squared times 4. I get 201.06. Volume of my cylinder, 1/3 times pi times 4 squared times 10. 167.55. Those two are going to be added together. And I get 368.61 feet cubed. Homework tonight's all about cones. Go ahead, try these problems in your book, see how you do, and we'll go over them tomorrow. Alright. So we have a cylinder with a radius of 5 centimeters and a height of 12. So that's going to be pi times 5 squared times 12. Gives me 942.48. And what would the height of a cone need to be if it had the same volume as the radius? So we gotta think this one through a little bit. So we're gonna have the same volume, so 942.48, and that's gonna equal 1/3 times pi times 5 squared, which is 25, and we're looking for that height. What you actually want to do here, what your best bet is you want to multiply everything that you can on the left-hand side together. So we're going to do 1/3 times pi times 5 squared, which is 25. And we get 26.18 for that. We have h. So we're going to divide each side by 26.18. The reason I'm dividing each side by 26.18 is because it's being multiplied times that h. And to undo multiplication, we're going to divide. So 942.48 minus 26.18, and we're getting a height, and we're ending up with a height of 36 centimeters. So in the second problem, Isaiah is making a cone-shaped ice cubes. We have the radius and the height. And we want, what would 10 ice cubes weigh? So we're going to find the volume of the cone first. So 1/3 times pi times 1.5 squared times 2. 1/3 times pi times 1.5 squared times 2. So we get 4.71. We're going to multiply this times the weight of 5.5. And we get a weight for each ice cube of 2.59. Multiply that by 10 to get the total weight, and we're going to get 25.90 ounces as our total weight. This gave us the weight of one ice cube, and then we had to multiply it by 10 to get the height, or the weight for 10 ice cubes. So today we're looking at the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So volume is 4/3 pi r cubed. All we need is the radius, so 4/3 pi times 8 cubed this time. So 4/3 times pi times 8 cubed. It's going to give us a volume of 2,144.66 milliliters. 4/3 pi r cubed. 4/3 times pi times 3 cubed. So 4/3 times pi times 3 cubed. I get 113.10 inches cubed with my rounding. Notice here I have my volume, so I need, or my diameter, so I need to divide by 2 and get my radius of 11. So 4/3 times pi times 11 cubed. And I get 5,575.28 feet cubed. Try these two on your own. Be careful to notice whether we're looking at a radius or our diameter. So for the first one, 4/3 times pi times 9.2 cubed. I get 3,261.76 meters cubed. Here I need to have my diameter, or my radius. I'm going to divide by 2. I'm going to get 17 equaling my radius. So 4/3 pi times 17 cubed. And we're going to end up with 20,579.53 centimeters cubed. So we have a volleyball with a diameter of 10 inches. That means its radius is going to be 5. And it can inflate the ball at 325 cubic inches per minute. So we're going to find our volume first. So 4/3 times pi times 5 cubed. And I end up with a volume of 523.6. We're going to divide that by the 325 because we want to know how long it's going to take to inflate. So we're going to divide that by 325 and we'll find out that it'll take roughly 1.6 minutes to inflate. Snowball. It's a good day to be doing a snowball problem considering we're going on our second day without school in the blizzard of 2016. So our snowball has a diameter of 6 or a radius of 3. So 4/3 pi times 3 cubed, find our volume. And we're going to find out that our volume of our snowball was 113.1. And again, we're going to divide by the 1.8. And we would find that it would take 62.8 minutes for our snowball to melt. Go ahead, try these two on your own, and then we'll come back together and go over them. So in the first one, notice you have your diameter of about 8 feet. So we're going to be using a radius of 4. So 4/3 times pi times 4 cubed. And I get 268.09 feet cubed for our volume. Number 4, we have 4/3 times pi times our radius of 1.2 cubed. And we get a volume for 1 scoop to be 7.24. I'm going to multiply that by 4. I didn't do it right. 7.24 times 4. I'm going to get 28.96 inches cubed for the volume of 4 of them. We're still getting total volume, so it still does need to be inches cubed at the end. Volume of a hemisphere. Hemisphere is a half a sphere. So basically we're going to find our volume of the entire thing, and then we're going to divide it by 2. So we're going to do 4/3 times pi times 5 cubed. And we get 523.6. We're going to divide that by 2 because we only want half of the volume. So that's going to give us 261.8 centimeters cubed. Same thing down here. 4/3 times pi times 9.5 cubed. We get a volume of 3,591.36. And divide that by 2 because we only want half of the circle or the hemisphere. We get 1,795.68 feet cubed. So that's it. We made it through our lesson on volume. Try the homework tonight. It should just be on spheres and hemispheres. If you have any questions, feel free to come see me.